Alright, now let's take a second and talk about the automatic power feed and how it works on this Bridgeport mill, and let's talk about the difference between how we're going to use it and how we use the power feed in the radial drill press project. So let's just take care of that right away. The power feed on the Bridgeport style mills is going to be for boring holes or reaming holes. We're not going to be power feeding our drill bits through, especially not steel plates, because it's just not designed with that in mind. It's for our fine, light cutting operations, which would be reaming and boring. So the first thing I need to do is, if I read the instructions here, it says disengage feed, warm when not in use. So we haven't been using power feed, so it's currently out of gear, and it says stop machine before engaging. So the machine stopped. Now if I pull this plunger out, I can rotate it around, and now it is engaged. So what you're going to notice when I turn on the spindle in a second is we're going to see motion. This is going to be rotating around. This is how we change the direction of the feed. So let me turn on the spindle and you'll observe that. So there we have it, we have motion. Now the last thing we would do is, while the spindle is on and that is rotating, if I pull this lever, you're going to notice that it's going to start to automatically feed the spindle or lower the spindle down. So let's just see what that looks like. So there you go. And if it comes all the way to the stop, it'll automatically... Who am I kidding? I can't talk over this motor. If I go all the way down to the stop, it'll disengage. And the good thing about that is we can have a repetitive disengagement point. So what I'm going to do is, after I load up my boring head and I get located over the center of the hole, I will set my table height to complement my spindle stop, and that'll be to where when the boring bar comes through the bottom of the part, it'll automatically disengage the power feed, and then I can raise it up. Now I could definitely not use that feature, but we're teaching you all the functions of the Bridgeport style mill, the vertical milling machine, so we're going to go ahead and use that. Now we've got our hole drilled, we're in the XY0 position, so I'm going to go ahead and switch over, take out this drill bit, take out the drill chuck, and we're going to put the boring head in, and we're going to go ahead and bore this hole. Since again, we're at the position that the hole is going to be bored at. We've drilled all the other holes, so we're going to save steps, and we're going to just do finish the hole that we're in right now. I've selected a boring head from inside the tool room. Now I'm going to go ahead and I'm going to load it up in the machine. I'll be using a 3/4 inch collet because this is a 3/4 inch straight shank. I will be inserting the boring tool all the way in the collet. I want to keep my setup as short as possible to increase the rigidity of it. And again, you notice I like to put my hand on the brake before I put the wrench on the drawbar, because I don't want to have my wrench on the drawbar stud and then unintentionally actually turn the spindle on. I know you might think that you would never do such a thing, but many people have. And if you look on a lot of our motors, you will see dents, and that is from people either leaving the wrench on, which is obviously a terrible idea, or they had the wrench on and they were going for the brake and they accidentally turned the machine motor on. So you always have to be very careful and try to develop muscle memory patterns. They're going to keep you safe when you're a little bit distracted. I've lowered the boring head to where it's close to the surface of the part but not touching, and you can see that it's currently extended beyond the inside diameter of my hole. So I'm going to go ahead and I'm using an Allen wrench, and I'm going to collapse or make the cut diameter smaller on the boring head. Now, if you focus on the tip and see how it relates to the hole, hopefully you can see that about now it would probably fit in the hole, and it will. So I bring it out till it looks like it's just about to touch. Then I come above the surface of the hole, and you might not be able to see this, but I'm on about the 38th division, and I'll go ahead and just adjust this to be on 0. Now, I like to always be on a whole number that's like a 5, a 10, because I can count by those numbers very easily. I avoid zeroing out or stopping on somewhat random numbers like basically 2, 3, 4, 7, 8, 9, 6. I like to count by 5s or 10s. It's a lot easier until I take my final pass, and that's when I want to make a precise adjustment. So let's go ahead and add a little bit of cutting oil to the hole and turn on our spindle and take a pass and see how this works out. Now, that boring tool gave us a very, very, very nice finish, and that's what you should see. Aluminum is free machining, and if I have a nice sharp tool and all my machine parameters are set appropriately, then we should get good finishes like that. Now, from the inspection cabinet, I just retrieved this caliper type inside micrometer. What you're going to notice is it reads backwards from what we've been used to up to this point, where normally we have our 0 and it goes up to 0.1, 0.2, 0.3, 0.4. Well, this one is got to be different because after all we are opening instead of closing on the part that we're taking a measurement from. So the smallest hole that we can measure is 0.200, and the largest hole is 1.200. So there's a 1-inch range, but given the fact that when I close this, the closest I can get these tips together, these are solid carbide measuring points, the distance from this edge to the far edge on the other one is 0.200, so that's why the range starts at 0.200. So I'm always going to use the ratchet thimble because I don't want to break these solid carbide points. So I'll go ahead and I will be opening it, and I know that my hole when I first drilled it had a diameter of 0.8125, that's 13/16, and I removed maybe 20 thousandths. So if I open this up until I get to the 0.8, then I know I should be pretty safe to go ahead and put it in the hole. And then what I can do is I can actually track it as I go. So I'm at 0 and I'm lined up with the 8, so I know I'm at 800. 1 revolution would mean I'm at 825. 5 more would be 830. 10 more would be 835. And there I am, so I know I'm at 0.836 on my diameter. Now, I'm going to make several adjustments and several cuts. The reason I start with a 0.800 hole approximately is I want you, the student, to be able to get comfortable with using the boring head and making the adjustments. And I would challenge you to try to land on, let's say, 0.925. And the reason I say that is if you can land or bore a hole to be exactly 0.925, then you should have no trouble finishing the hole at a diameter of 1.000. But if you go all the way to the hole size of 1.000 without ever checking to see how accurate you actually are, well, you might just find out that you end up with a hole that's 1.005. And what you've done is you've wasted an opportunity to verify your own accuracy as you approach the finished size. Now, when you become experienced, you don't need to do that, but you should always be measuring as you go and tracking your progress. And if something doesn't add up, then you need to stop and figure out what it is.